Hello, everybody. Thanks for coming here to the Microscope meetup. Today we have here Adrian Cole. I think that this is the second time he presents on this meetup.
That's true.
And the first one was about distributed tracing with Zipkin.
That's right.
Okay, and now basically he will present. Basically, the title of the conference is Observability 3 Ways, and he will basically present about logging metrics and tracing. Okay, so you will enjoy this presentation, and if you want to enjoy also a beer, you can basically order a beer and enjoy it as well. Okay, yeah. Thank you.
Yes. So does this thing work? All right, cool. So yeah, last time I noticed people weren't paying enough attention, so we now have the slides next to the alcohol, so make sure it gets the full attention. So anyway, yep, thanks for the intro. And let's dig into it. So before I made this presentation, I went around and I asked a whole bunch of people what they thought about this observability space, logging, metrics, and tracing, because there's often a time when there's some confusion about what tools to use what for. And so sometimes through this talk, I'll mention like who comes up with an idea, because it's usually not me. So Coda Hale, who's done some pretty cool libraries, some people may have used for like Java metrics and things, mentioned something important to help us like tease the differences between these tools, and that there's a unifying theory, this being that everything at the end of the day is based on events. Like, given events, you can make other things. Event can be its own, but without these, you have nothing. So logging, we're recording events. They're stateless usually. And you know, given these events, you can create, you know, aggregate events from that. You can scrape these logs, or you can parse things out of them. Metrics, in fact, is sometimes created from log events. Because people are scraping data out of it, and then they're collecting, okay, this into a rate that's then published as a gauge. So metrics is an example of where you're taking events, you're combining them together, and then you're making a new event out of it. Tracing, the key part here, which I think is nice to kind of remember tracing's place, and when I say tracing, I'm using it synonymously with distributed tracing. But tracing is not just recording events, but also keeping track of what caused what. So you can, in a normal log, you can look at timestamps and you can sort of say, oh, this causes this because this happened before this one. But did it happen before it because your clocks are out of sync? Or did it happen before it because it happened to happen before it? Or was it caused by the previous one? The difference for tracing is that you can tell what caused what from what happened to share time with something else. Peter Bergen is another person I was talking with. He is a primary developer of a microservices toolkit for Go called GoKit, and has done a lot of work at SoundCloud and some other places. And when talking about these things, he said that the important thing is to look at what they focus on, because we have different tools, and yes, they can do a lot of things, but what is their cardinality? What is their key trait? What can they do best? And in this, if we talk about these things going through the system, well, metrics clearly is best for statistics and aggregations and letting you reason with a population of values. And on the other hand, logging is, you know, can be just about anything. It's like a crazy exception happens, or an audit event occurs, or garbage collection happens in some garbage collected app that you have. And at the end of the day, its key focus is the event itself. It's being able to capture just about anything and plot it over time. tracing, yes, it's about events, but there's also a request scope nature in tracing. So for example, in tracing, usually you're talking about one thing coming in causing many other things. Well, that is pretty much a request scope if you think about it. And so tracing isn't very good for telling you about garbage collection because that is a shared event across many things. And tracing metrics and logging have overlaps. So for example, there's certain things you can do with all three. Like you can look at latency, which is going to be the rest of this talk, with all three. But you can also create latency metrics out of just the fact of duration from tracing spans. You can harvest tracing data from logs, and you can also co-plot them if you have a correlation identifier. So they live in the same space and the tools overlap, and that's why we sometimes get them confused. But they do have some focus areas that are of importance to us. And kind of foreshadowed this, but let's dig another way by looking at something you can do straight in the middle, and something that's near and dear to all of our hearts, which is response time. The only thing worse than a server that's down is one that takes very long time to say crash. I skipped one thing here, and forgive me, my presenter notes are not showing, so I have to recall. Throughout these tools, yes, they have focus, but they also have primary data types. So when we look at logging, yeah, the event, usually timestamp, message, maybe some contextual metadata. Metric, the primary thing is a value. Some systems only take a floating point number, but many of them will do things like dimensional tags and all this stuff. Tracing, at the end of the day, it's almost always a tree, although some systems like htrace can do graphs that are not in shape of a tree. So I took this because I think this is the first time I ever looked at latency, was just looking at some log output from some common log format. And when you look at logs, because each one can't necessarily be dependent on a prior log message to give you value, because logs are lossy systems usually. One thing about this is interesting is that it actually occurs in a point in time, but it also tells you a duration, which is the latency there. A lot of times we're looking at 2 log lines and then doing some math to figure it out. This is an example of where a log can do latency by using a formatted field. And from this, if we knew the format of that field, then we would know to look at the last thing past the slash before the quote. And that would tell us that how many microseconds occurred. And so voila, with a simple grep or any given tool, we can know about latency of this request. Using my favorite tool, MonoDraw, which lets me do things in ASCII art. Okay, a little bit intruded by the alcohol. You'll have to drink faster because I need to show you the bottom of this slide. Anyway, at the bottom we have buckets of time in 5-minute increments. And then I'm using some classifications where I have bucketed latency into these patterns. Like I made a bucket called odd, which is something that's too fast. And a bucket called bad, which is something that's too slow, and some things in between. So using metrics, depending on our tools, we can often tell not only the quality of 95 milliseconds, is this good quality or bad quality? Because honestly, there's no right answer to 95 milliseconds. But also we can tell how a population of requests were doing at the time that this had a quality. So for example, it's much more notable if something is very slow during the time that everything is very fast than everything just being the same thing at the time. So metrics are really cool because they help us qualify things. particularly among peers. And yeah, I mean, this is also, we always put alerts on metrics, right? So metrics are nice because they're dealing with a population. They're resilient also to data loss because you have enough readings that you can make a guess. And if that doesn't work, we do what we always do, which is like retry 3 times and see if it's still the case. Traces are, yeah, they're looking at a single request as it passes through the system. One way that's common to render a trace is an icicle or waterfall, or however you would like to call this view, where the critical path, which is what the client is experiencing, is on the very top, and it's often the longest bar, but not necessarily. And then as it breaks down, you could tell which of these operations caused by the top contributed to the latency you're seeing. And so if I had the same fact, which is the 95,491 microseconds, I can now understand why. Not just what or what context, but also why. And so, for example, these yellow blobs here in my system might indicate this was a failed network attempt, which it resolved on its own silently. The user is probably happy that it was slow because it still succeeded. And if I take that out, I would find that request, the good parts of the request finished in 55.7 milliseconds, which at the time would have been darn pretty good. So we can understand. And so that's how these 3 tools sometimes can give us co-presented sometimes even on the same utility if you're using an APM or performance tool, the same type of activity in different ways. So you take your own takeaways, but these are the things I think are the salient points. And I'll put the slides up in case you want. So how does this happen? So first, everything starts in code. So how would we write the code to do these things? And at the bottom, I have a highlight, which is that there's a jargon here, the span word. And so span is like a made-up term, time span, maybe, probably. And this is one of the vocab that's used in tracing to differentiate one bar in this from the entire trace of bars. So a span is one line in the whole trace here. So at the end of the day, when we're doing tracing code, or when we're looking at timing code, logs, we need to capture the data and then stuff it someplace. And metrics, usually we're just storing a single value. And we'll look at how tracing works. So I ripped some code out of OKHTTP and pasted it here for you. If you turn on the wire logging, it would literally do this, string cat. So in this case, something had prior done some Java code to capture the nanotime of when the request started, and then splats out the value after converting it to milliseconds. And so, logging is, we sometimes look at logging as we're parsing things because we never interact with the code. But of course, you may have actually been the one that coded that format. It'll look like this. Metricing looks a little different. And of course, there's many libraries for doing metrics. But if you were to look at this is from Finagle. You would have something that surrounds your operation and then report into your stats receiver how many microseconds it took. And microseconds is an interesting unit of time for duration because it can show you some local activity. Like usually you're not going to have precision better than microseconds in clock time either. So it's a nice way to report things that gives you some granularity to catch weirdness without being presumptuous about nano precision clocks that don't usually exist. But sidebars aside, I think this is the easiest programming model because you have one thing, you add a value to it. Someone configured it beforehand. So in this case, someone's put a label for request latency, microseconds. Many libraries will allow you to take a collection of tags and pre-configure them. And then at runtime, it's simple, very high performance, just drop values into it. Tracing is the hardest from a programming perspective because it's a stateful idea. So when you're doing metrics, you're plopping down floating point numbers, and then some aggregation might be happening. Logging, I just need to fire this log message, and I'll fire it again if it happens. But in tracing, you need to know that you're connecting the parent to the child. So there's state there. You must know what that context was of the parent before you can know which child is this. So in Go, there's Go context library that can help you pass data across requests. In Java, we have things like thread locals, and every library has some blob of properties you can stuff things into. In tracing, you need to find a way to pass this causal information along the path of a request. And so as it exits the process and enters the next one, if it's an HTTP-based system, then it's usually going to be headers. And in fact, it's also, if it's a messaging-based one, it's usually headers too. So the propagation concern is not only inside the process as it crosses threads, or if it goes onto a queue internal to the process and needs to pop back off of it. There's a propagation inside the process, and then there's another one to the next process. So that's kind of hard. And actually, if you solve that, you've solved 75% of the problem. Because doing stopwatches and things is not that difficult. So impact. Logging, you don't really have to teach anyone how to do logging. You have to teach them how to do logging well. Logging is, everyone knows how to print foo. And metrics, I think, are less popular, but they're also stupidly easy to use. Type safe is very nice. Tracing is the hardest because of this propagation concern. But you get a lot for that. You get this parent-child relationship. You get a model that you can draw that's realistic and likely to represent what's happened. And so I would follow this with, should you write timing code? And in most cases, no. Unless you're like Shipstead and have people who are developing software for cloud platforms and things like this, then you don't have to maintain platform code on your own. But somebody does. Usually they're framework authors or framework extenders or doing system coding because they have latency as a product requirement. But average use cases, you probably can get away with what the frameworks provide, or things like agents. And the timing code, while tracing isn't universally present in frameworks, metrics usually are. So it's a rare web framework that has no means at all to report metrics. The other thing is that there's a lot of, even though I made fun of it, saying stopwatch is easy, it turns out that stopwatch is actually hard because the time can change in between, and how you're measuring things, you can accidentally create latency in the process, and there are definitely edge cases which are weird, and they can steal your time. No pun intended. So how do you not see tracing code? This is a new section, hence the hazard sign. And I have no notes, so it should be even more hazardous. But I think that there's generally 3 ways to avoid writing tracing code. One is to have some sort of a buddy who traces your process for you. And another is an agent, something that you strap onto your process, which does basically the same thing by patching code. And then the last is the most common, I'd say, where you have frameworks who are configuring things that already do things like tracing. So buddy tracing is not like the best keyword, because I should say service mesh, because that's very hot now. But that's basically one of the main features that service mesh provide these days. So for example, there's Istio, which I've seen some tweets from Velocity talking about. Linkerd is another service. And then there's obviously lots of sidecars that existed before these things, Prana and things like that. Many of them have different features where they help with the communications in between your applications. They do some sort of man in the middle. So in this case, this was an image taken from a recent Linkerd blog. And so the yellow bars here are where the actual proxy are taking requests, and the blue is where they're actually sending them to the real servers that exist. So for example, if you can't read it, there's an external request into Linkerd. Linkerd, on behalf of that, calls a real web service. That web service makes an outgoing call back to Linkerd because it's been patched into its routing tables and things. And that in turn knows which services it's supposed to go to and routes it accordingly. There's gotcha here, which was not on their blog, but it was actually in the bottom. But I added an arrow. I need to congratulate myself from patching their thing, which is that something is propagating headers there, right? Because there's no magic way to know that the below requests were related to the above requests, except for heuristics like snooping around and guessing. So in a buddy tracing system, usually there's a requirement for the things in between to pass a header pattern along. So like for example, in Linkerd and also I think Lyft Envoy, they basically tell you like, X whatever or like L5D dash whatever, make your web frameworks pass this. Don't drop them, because otherwise we have no choice but heuristics to figure out who called what. And that's not great for causality, is it? You don't want to be guessing. So you pass the headers and you're done. So they service mesh or service meshy, I think, trace your services. Another way, and this is Java code, this is a little bit more explicit than is required. There's higher level Java libraries for making agents. But agents we hear about most often from black boxes, but this is what they look like inside. So if I have New Relic agent or AppDynamics agent or something like this, what is it doing? It's patching your code, man. Like it's actually looking for types and sometimes adding fields to your code to store state for you. And so we have ways of making you trace. Like it's doing it whether or not the library wanted it, it doesn't matter, because as long as there's a stable way to do it, agents can do anything. And so in this case, we're saying we're looking for this path for Jetty handler of the Spark web framework. And we're going to patch into the do handle method. And on argument number 4, I think 0 is the current object, we're going to call setHeader and add our magic trace ID to that. And so this is very, very, very powerful. So this is why APMs make agents, because you get the most power if you can actually change the code. Framework tracing is where is something we do all the time, actually. There's already code to do things like metrics and tracing in a lot of libraries, but you don't want your users to always have to know how to configure this, and then configure that, and then configure that, because it might be like 20 different things. So frameworks like Spring Boot, in this case, this is Spring Cloud Sleuth, a code I just ripped out for the Hystrix instrumentation. And so it would do some detection to see if certain things are present, and then make decisions automatically on behalf of the user to do things. And this is nice because it gives you automatic tracing. It doesn't require you to run an agent. Also, there's another side effect, which is that this code is a little bit more straightforward than writing this. So it's a little bit easier code to maintain. And you might be able to get the person who wrote Hystrix to review this. Also very important. One of the most important things I think in tracing is actually making sure the framework authors are the ones that are helping with decisions on how to trace their stuff, because they know where all the bodies are buried. And so anyway, there's a lot of advantages to this. The disadvantage is that it adds another dimension to your dependencies, your library dependencies. And so it may not be compatible with everything at the same time. And so you have to like look and see what's supported for whatever matrix of things there are. So that section I was just talking about different ways that you can do tracing besides rolling your own. And now we're going to switch gears back up to the architecture level again, because we went pretty deep down to code, like down to the gnarliest. And all right, now stuff for doing things. How does that actually get into the tracing system? So yeah, they all have actually, I mean, sometimes you use the same pipeline for all of this stuff. So there's some flexibility here. And that also helps add to confusion because it's like, hey, I put everything in Elasticsearch, so it's all the same. But the way it's done is what's different about these things. So for example, in logs, usually you're pulling these raw events, but then oftentimes there's some parsing going on and indexing based on what tokens you've parsed out of it. Metrics, they don't really they don't report their populations. They report summaries, so histograms or some sort of a stat that's like bucketed beforehand. And traces, are a bit specialized. And one thing that's important for tracing that may not be as important, but is increasingly important for the other systems, is the near real-time nature of it, because it's a troubleshooting tool for your live production. People generally expect a second readback from the traces, or sometimes log and metrics data, you can, because it's being summarized in the first place, sometimes people can accept minute latency. And I say this is like a work in progress because if you read most APM vendors today, like they're like, I have 1 second, 1 second granularity. Why? Because functions as a service, like they start and stop before a minute. So you need tight granularity. So a lot of these things are changing, and probably at some point, 1 second will be too coarse-grained. Anyway, if we're in parsing land, then we have lots of cool tools. If you recognize this, then I don't have to tell you what it is. But if you didn't, there's a log stash is one way of schlepping things from log files or other sorts of repos, usually files, and then somehow filtering it so that there's a way to reason with it. And because we've been parsing things for so long, we actually have tools for parsing, like Grok, which can allow you to archetype certain types of patterns, so everybody doesn't need to have like a black T-shirt that says how good at regex they are. Bucketing duration is like the key thing underneath of the scenes for metrics, and of course it's not required to do this manually. There's high, dynamic ranged histogram. I think HDR histogram. I think is that. But let's just say that you, if you want to be able to take summaries from 2 different systems and combine them together, then you need to know like categories to place them into. Otherwise, you have the problem of like adding averages together, which is that you don't know how many requests made up this average. So you don't know if you add 2 together is basically nonsense. So buckets are a really good tool for latency metrics. And so in this case, this is actually code that has changed since I pasted this, but from a new project coming out from Google called Census, which is their metrics and tracing library that is basically behind the current version of Dapper. And in this case, there's some pre-selected categories, like I had in my ASCII art diagram before, of like what latency values are important. And then instead of sending over the wire every single value, we just send the sums. So for example, this is really important in a section I'll get into next about the dynamics of the size of data that's going across the system. Trace data tends to be the largest per unit, but it really depends on whether somebody's put a PDF in a log message or not, because definitely logs can be anything. But spans can be pretty big data, and it's request sized. So if you're not careful, your span, which might be JSON or might be protobuf or whatever your rendering is, can be larger than the actual request object itself. But this is an example of a Zipkin span and microseconds timestamp, and there's data structure there. There's varying levels to how structured span data is. For example, Amazon X-Ray chose to be a lot more data structure, like they have more structure in their data than some other trace formats, because they have some constants. Like they know that there's going to be availability zones and there's going to be these services, and they know how their APIs work, that they have retries and counters and things like that. So by overlaying this, they can get a lot more information to the end users of this data. So when we look at this data, okay, after these things have created it, how does it grow? Because one thing at Twitter we had a problem with was that very small percentage of the data that was ever written was read back. So and it might be very, very low percentage, and it will scare you how little sometimes the data that is sent is read. And so this can become a storage problem. Logs, generally speaking, they are a function of traffic, although they're also a function of other things, because logging captures everything. So you have external events, you have deployment events, bootstraps, you have actual lines because of requests, but you also have a lot of static and system-related coarse-grained events like garbage collections and things. The neatest thing about metrics is that they're fixed size with regards to traffic. And this gives you a lot of power in how you deal with metrics data, because presuming you don't do like dynamic dimensions and things, you're guaranteed that regardless of whether whether you have a traffic spike or not, your metrics is not going to end up with more data in it. The only thing that actually tends to change your metrics is the increase of counts of endpoints, which now that we're in a world where we deploy 48 times a day, may be a problem. But generally speaking, the nice thing about summarizing data is that the size to ship a value of 1 is not really that significantly different than the size to ship a value of 1,000,000. They're usually sent with the same binary encoding anyway. And even if it's fixed, it's not 1,000,000 times larger. Traces grow with traffic, and so we have some interesting ways of dealing with that, including sampling. So I actually asked a lot of people, and the first thing everyone offers to me without me even asking is don't log things that aren't relevant. And that's because we've gotten to a world where logging is easy and we just log things. And so our first tools for defense are not logging things that aren't important to us and filtering out the things that we can't turn off otherwise. Metrics, you can do some experiments to like what things are you writing but you're not reading ever. Frameworks can sometimes be guilty of over-metricing things. So like we have a problem when we have no metrics, but we also have a problem when, oh, I should put a metric. Oh, I should also put a metric. Oh, and then no one reads those metrics. Because again, metrics are a function of the count of things, not the values going through it. So one thing I have definitely seen in code is that people get a little bit overzealous and they have like 7 metrics per file. And that can be really not helpful. And why is it not helpful? Because generally as programmers, we're not great at guessing. So it can be difficult in code reviews to encounter code where someone has, with great intent, added different metrics with maybe some good explanations. But there's always a trade-off. Tracing. The primary defense is sampling, especially with high traffic websites. If you have a lot of 500s, you probably actually have a large reason why 500s are happening, and one 500 will not necessarily look very different than the other 1,500 errors that happened at the same time. So if you have a high traffic system, you can choose 1% instead of 100% of the data, because you might get lucky. There's also a side trick that I learned from the Census folks last week, which is that in this library, they're actually keeping local to the process all of the trace, every command, and just on a ring buffer that will overwrite itself once it hits a certain memory size. And by doing this, even if you don't have a distributed trace that goes through like all of your endpoints, you can connect like an admin port basically and query the data it has available to itself and at least know who caused it and what it caused, even if you don't see the entire tree. So there's some tricks to making even a aggressively sampled thing where you might be like sampling 0.01% of traffic still have some value of tracing in between. So we're getting more sophisticated over time with sampling. The other thing to think about is that all of these things have different retention policies, or at least they have the chance of having a different retention policy. If you clobber everything into the same index, one problem is that you're forcing everything into the same retention policy. And that's usually the longest one. So if, for example, if you have some policy where you're required to have logs for 90 days, and you put your trace data in that exact same thing in a way that you can't prune it without pruning logs, then you just inherited 90 days worth of trace data, which you probably are not going to be very useful to you. The average retention of trace data in systems that I've seen in Zipkin world and related Zipkin worlds like the forks of Zipkin and things are like 2 days, 2 days to 7 days. So it's a very short period of time. It's just to troubleshoot production. It's not just say like, what did this trace look like 3 years ago? That's not usually the case. What happens is that the trace data goes through the system. You might do some fancy things like make a Netflix visceral model and then just drop the data after a couple of days. That's it. But again, if you put them all in the same bucket, then you're a slave to whoever needs to be held the longest. Anyway, so let's just stitch it all together. One of the goals I had with this talk was to kind of do some comparisons using different ways of looking at observability and how these things are coded and how they impact your system, because tracing, logging, and metrics are are things that we sometimes confuse. But sometimes we want to conflate them. We don't. It's not that we want to conflate tracing with logging, but we want a connection between tracing and logging, because we're trying to observe our systems. We don't want to have 3 different ways of relating to the same request. So correlation is the thing everybody uses for this problem. So to stitch these together, there are some dimensions that are compatible. So for example, if we go back to Peter Bergen's 3 circles thing, how do you connect? How could you connect these things together if they live at different levels of granularity? Well, metrics and traces. We often have endpoint metrics, don't we? And so endpoints are what receive requests. So there should be some common dimension there someplace. Maybe it's an RPC name if you're using gRPC or your favorite thing. Maybe that's actually the name of your span. And then that means you could correlate and at least have a label that's common between these 2 views. When you're looking at logging and tracing, the thing everybody does is plops trace IDs in their log files. And if you're Java, you'd be using the message diagnostic context of SLF4j or log4j, and you just plop it right in there, throw it into Kibana, churn it out, and now you can put same trace ID and hop between your utilities. Why? Because logging and tracing share a request scope. Even though logging is more than requests, it also does requests. So you can hop across there. Rollups. So if you live in a world where things are clustered, then cluster is probably a common aggregation for you in your metrics. And you may be able to actually use that same dimension as a key, another key that you're adding into your trace data. And it may also be something that you could plop into your logging context as well. So you can do rollups by cluster or IP or what have you. So the thing is that you can actually stitch these tools together. And if you're using an APM, you'll notice that they do this. So when I use the word APM, application performance management tools like New Relics and AppDynamics and things, they often have the ability to hop between screens and hop between views of things. And they're using common dimensions to do that. And so if you break it down, what's underneath of these screens, there are metric systems, there are tracing systems, there are libraries that create this data and people who tend to that data. And there's definitely ways for us to transition and get the most understanding by employing them together. So I call on to the leverage the strengths, understand the weaknesses. Like all things, there's no golden hammer, but there's some pretty good hammers. And they're all very good hammers. And there's some use cases that even if you hate logging, you're going to need it. Logging is great for monoliths, by the way. And there's still a lot of monoliths out there. You don't need distributed tracing if everything is in the same process because it's not distributed. Also, black boxes, you have no control over the code, but you can scrape its output. That's probably not going to go away. Exceptional, and I'm meaning this from like an error condition. Oftentimes, people do not anticipate all the error paths that are possible, and so they will miss something. And an error bubbles out, the metrics didn't catch it, the trace didn't catch it, whatever. You're still going to need exceptional cases with traditional logging. We know that metrics is great at statistical stuff and slicing and dicing, and that's why we put alerts on things. That's why we look for patterns there, and tracing, if nothing else. It's the why is this slow, but it's also something else. I have other talks about use cases of tracing, but what did I just build is probably the other main use case, because especially when we have different abstractions, we have meshes and layers under those and under those, it's very difficult to hold in your brain everything that's going on in the system. So understanding your system and like a path a request takes is actually a pretty valuable thing that tracing provides you. On the other hand, tracing is not good for understanding GC. So like there's things that it's just not good for. So anyway, if the most content except for the hazard slide was helpful, then these are the people that helped you. Like I run a distributed tracing workshop. I'm actually going to that after this Monday. Some of the people will be there again. But Peter Bergen, actually, if you go to his blog, this 3-circle thing, actually that was the inspiration for my talk. He has a nice blog that predated this, and he has some other interesting pieces as well. Baz also works with Peter on GoKit and is also a Zipkin contributor. Bogdan is the lead of the Census project and Dapper at Google. And he definitely helped not only with this code that we can now see, but also a lot of insights along the way about why people do the things they do. I'm very much looking forward to some of the tricks that's going out in their code base soon. PH is from Criteo, and they have one of the things that we are getting more accustomed to are polyglot environments where we're running different applications, and there's no stranger here. Focusing on the system dynamics is important, and he helped focus this presentation in a way that it wasn't too biased. Nick Monroe is in charge of Nike's Edge applications. He has some pretty interesting projects too. If you look at Nike's open source, they've started to do a lot of things similar in nature to some of the Netflix open source stuff. Coda Hill I already mentioned. Felix authors a open source APM called Stage Monitor, which you can put a Java agent on, and it will start doing tracing and metrics and all that stuff. And Abhishek is from Amazon on the X-Ray product, which was released very recently. Actually, I think it went live, like as in the billing you just only May, but you can find a lot of cool stuff on X-Ray now due to the work that they've done internally. So anyway, if you don't like any of it, you know how to blame me. On Twitter, it's Adrian F. Cole, or you can blame me directly now. From a questions point of view, we probably have some time, I don't know. But I also can just show things off. I do maintain the Zipkin project, so if you have any questions about that, I can answer too. But yeah, over to you. Otra vez? So I'll show you this cool thing real quick, because might as well, right? I mentioned some things. This Open Census is not really live yet, but this is your sneak peek. I think they'll probably be doing some press release soon, maybe in the next few days. And it's a library that it does both metrics and tracing. And very interesting. They use different APIs, but underneath of the scenes, they can do some cute things with this. So for example, in Open Census, the propagated data is compatible between the metrics information and the tracing information. So for example, if you need to look up your metrics by customer code, you can actually add that to the context, and it will hop along so that every single thing can be logged with that code that you only know at runtime. So it's pretty cool. The other thing is they have a few languages here, but this came out of the Stackdriver product, which is in the Google Cloud. And they're going to be recreating a lot of the instrumentation that already exists today, harvesting from those projects. If you're interested in Java, one of the things that's neat is they're starting an agent, so you can make your own monitoring agents, which is kind of neat. And the other thing was that this is the observability library used by gRPC. So if you use gRPC, you're going to be using this. And so this collects all the statistics and stuff like that. And I can probably show, I'm trying to remember, you can see Android directory. That's another foreshadowing. Let's see here. Test, no, not that. I was talking to you about bucket boundaries. So the code about how to make histograms and things like this is in the box. And they also have hooks for doing custom aggregations. So how could that be helpful? So if you want a feedback loop in your process as your requests are slowing down without feeding back through your monitoring system, you can put a handler in here. So your app itself can know as it's slowing down. How could that be helpful? Well, if I'm doing tracing, I can start to increase the amount of trace samples I get for processes that are starting to become slow now, without a central coordination from Zookeeper or something like this. So there's some pretty powerful things when you can do local aggregations inside the process. So anyway, keep an eye out on Open Census. I think it's pretty cool. Also in this type of space, there's this thing, Open Tracing, which is an attempt to do standard API programming for tracing. And so a lot of the terminology and use cases are documented here. And they have a bunch of GitHub projects for those who are writing tracing frameworks. So for example, some people who are making agents are writing their code with these libraries. And then I mentioned it before, but X-ray is pretty hot stuff. So if you're in Amazon, which many people who are in a meetup like this might be in, have a look. They've got some pretty cool stuff. Recently, they added the ability to like auto trace around functions like the Lambda services. So for example, what does that give you? It gives you the ability to know when Amazon started creating your function. You can't see that data, right? So you only know if you're deploying a function, there's some warm-up time before it's hot and everything else like this, but you can't see it because your app hasn't started yet. It can't start logging these messages, right? So one of the nice things about the clouds who are starting to get involved with distributed tracing is that now they can show you information that only they had access to before. So if I have a slow function, then I could pull up a trace and it would tell me, okay, well, it took 3 seconds booting up. And again, there's no way to know that otherwise. And you can expect Google to do the same sorts of things. So for example, if you have some sort of a cloud data flow pipeline someplace, in the near future, you would be able to see when it crossed the line between being in your code into Google's code or Azure's code. So these are some things that are pretty neat. And then on the logging side, I saw something really cool the other day from, shoot, forgive me. I need to look up myself. Who made it? I don't want to get the cloud wrong. Ah, here it is. It's Google. Adding log statements on the fly and have them expire. That's like the coolest function as a service use case, in my opinion. So in Google's logging system, you could actually add here, I don't know if you can see it well, but you can put a log point in, and then if you do nothing, it will expire out of the system in 24 hours. So you know how terrible it is when we accidentally leave like too much verbosity in our system. So you're debugging something. Now you put in some log statement. This function will expire later. You don't have to think about it. So I love the fact that observability, people are pushing boundaries. They're still using, at the end of the day, some primary tools, logging, tracing, and metrics, but they're finding different ways to augment them using Lambdas or supporting Lambdas and stuff like that. So just keep an eye out. Some pretty cool stuff. So that's the end of the second presentation.